This is lesson 9.4, solving quadratic equations using square roots. So I'm going to start on page 392 because you guys don't start till 26, and these were some good examples that we haven't used. X squared equals 256. So that means that whatever this is just whatever x is the square root of this number. Because to undo a square, we use a square root. So the square root of x squared is x. The square root of 256 is 16. You can just use your calculator. If it comes out as a perfect square, like it comes out as a whole number as the answer, then go ahead and use that. So like this is plus or minus 16, because 16 times 16 is 256. Negative 16 times negative 16 is also 256. I wish one of these was not, like this one doesn't come out as a perfect square. I'll see, I think I have another example that I can do like that. All right, so x squared equals 144. The square root of 144 is 12. So x is plus or minus 12. X squared equals negative 20. So this one's a little tricky because not only is this not a perfect square, but it's a negative number. The reason that there are both a positive and a negative answer is because if I multiply a negative times a negative, it still gives me a positive answer. So if I take the square root of negative 20, there's no real answer that works for that. No real answer. Only imaginary answers when there's a negative number. I'm going to go ahead and do this one because I don't see another example like that on this page. X squared equals 91. So you take the square root of both sides. But 91 isn't a perfect square. So x equals plus or minus the square root of 91. And then you want to make sure that there's nothing that I can take out of here. 91's factors are 1 and 91. 2 doesn't go in. 3 doesn't go in. 4 doesn't go in. 5 doesn't go in. I'm pretty sure this is a prime number. 6 doesn't go in. 7. Oh, wait. 7 is 7 times 13. But those are also not perfect squares, so I can't take anything out that way. And then 8 doesn't go in. 9 doesn't go in. 10 doesn't go in. 11 doesn't go in. 12 doesn't go in. And then we're back to 13. So those are all the factors. And none of them are perfect squares. So you can just leave your answer like this. Okay, so the trick with the factoring, see how this is a really big number. Once I go back around and hit the number on the other side, I don't have to go any further. There's not going to be anything else higher than that. So once you go 7, then 8, 9, 10, 11, 12, you don't have to go past 13. There's not going to be anything else. Other numbers would be too big to multiply and make it 91. All right, so those are the simpler ones, especially these. You can kind of look at them. If you don't know your perfect squares or if it's a bigger number, just take the square root and make sure, like, if it's a perfect square, you give the whole number answer. I have seen people want to leave it as like the square root of 9 or something like that. You just put 3. All right, these are a little trickier. They have a couple more steps. Oh, I was going to do these. I'm going to do this on a separate piece of paper. So I've got 2x squared minus 7 equals 38. So I want to get this down to just x squared on this side. And I've seen some kids struggling with solving equations still. Remember, it's kind of like you go backwards through PEMDAS. You don't want to start right here where the x squared is. You want to start over here with the minus 7. So I'm going to add 7 here and add 7 here. These cancel out, and I just bring my 2x squared down. 38 plus 7 is 45. Right? Yeah, that's right. That's kind of sticky. I divide by 2. I get x squared equals 45 over 2. So I got to take the square root of 45 and the square root of 2. If you write it this way, it's easier to think about. Oh, this is a good example, actually, because we had another weird one like this in class earlier. So the square root of 45 I can break down. It does have a perfect square factor I can take out. So 45, I've got 1 times 45, 3 times 15, 5 times 9, and that's where I want to go. So then 6 doesn't go in, 7 doesn't go in, 8 doesn't go in, and I'm back to 9. So 9 is a perfect square. So this is the square root of 5 times 9, and I can take this out and make it a 3. I'm sorry, this has the square root of 2 still under it. So this is, I take the 9 out, and it becomes 3. I leave the 5 under there. But this is why my answer didn't match the book's answer earlier. They don't want any radicals in the denominator. I'm not sure what you use this on in later. I think it's just because you have to have like, I'm not really sure what difference it makes now. I'm sure that later on it will make a big difference. So they don't want any radicals down here, which means you can't have this square root symbol down here. And in order to undo that, I have to multiply everything by the square root of 2. The square root of 2 times the square root of 2 is 2. Think about it like the square root of 2 squared. You're multiplying something by itself, and then the square undoes the square root. These I get 3 square root of 5 times 2. Three square roots of 10 over 2. And just think about if 10 has any perfect square factors real quick. 1 and 10, 2 and 5. Nope. So this is the answer. X equals 3 square roots of 10 over 2. All right, and then number 17, I will say though, the quiz that we're going to have, you're not going to have one like this, but you may have 1 or 2 questions in your homework that's like this. Let's see. I also wanted to do number 17. We did one like it in class. but just in case you missed it, we have a right triangle here. This is 5x, this is 3x, this is 50. We know with right triangles, the longest side is across from the right angle. You should have learned this in in 7th grade or when you were doing pre-algebra. This is A, B, or you could say this is A and this is B. It doesn't really matter. But the long side is C. And we use Pythagorean's theorem, which says A squared plus B squared equals C squared. All right, I'm going to also do this on the other piece of paper. So we have 5x, 3x, and 50. Oh, wow, that's the ugliest triangle ever. 3x and 50. So A squared plus B squared equals C squared. Works for all right triangles because math is kind of cool. This is A, this is B. Felicity's giving me looks. This is C. So I plug them in. 5x squared plus 3x squared equals 50 squared. Again, see how those parentheses make a huge difference here. The x isn't just squared, the 5x is squared and the 3x is squared. So we do 5x times 5x. So 5 times 5 is 25. X times x is x squared. 3 times 3 is 9. X times x is x squared. 50 times 50 is 2,500. Because 5 times 5 is 25, and 10 times 10 is the 100. All right. Now, since this has the exact same variable and exact same exponent as this, I can add these together. 25 plus 9 is 34x squared. Oh, shoot. Do you have your calculator? Can you pull up a calculator?
Sure. Oh,
yeah, that's fine. So we got to divide 34 on both sides. X squared equals, yeah, I'm not going to try and do that in my head. Can you do 2,500 divided by 34? Yeah. Oh.
Can we write it down?
No, it's a decimal answer. So we don't want decimal answers. But this here was 50 squared. And we want to find the square root. So guess what the square root of 2,500 is? It's just the 50. So we can do this. The square root of 2,500 over the square root of 34. Oh gosh, this is another weird one with the thing in the denominator. So x equals 50 over the square root of 34. But you can't have this down here, so you multiply by the square root of 34 again. And the square root of 34 squared is 34. So x equals 50 square root of 34 over 34. That is not a fun answer. When we did one in class, it came out as like 5. But that's the answer. All right, if you guys have any questions on the homework, hopefully these were stickier than anything you have to work with. But make sure that you circle anything and ask me questions before you have to take the test. Have a good night.